Okay, so I've been playing around with this nano VNA and got to the point of downloading the manual, which helps considerably because otherwise you're in the dark a lot of the time. But it's a good manual as well. It all makes sense. It's not written in Chinese English, so that was nice. But I found this thing, as well as the normal functions you use it for, it can be used also as a time domain reflectometer, or TDR. And the use behind one of those is, if you've got a piece of coaxial cable of an unknown length and you want to know how long it is, you don't want to measure it with a tape measure, and you know the velocity factor, that's crucial. You've got to know the velocity factor. So you put this thing into TDA mode and connect it one end up, and if you've got no termination on the other end of the coaxial cable, open circuit or short circuit, then all the energy that you're sending down to the end will get reflected back. And if you can measure the time that takes, you can then work out how long the piece of cable is. And of course you have to know the velocity factor to get it accurate. So what we do is, I'll do an experiment. We'll put it into you have to put transform on. I'll go back a bit to the beginning. Okay, first of all they say set your star frequency to 50 kilohertz, and the reason is for that is, if you're measuring a very long piece of cable, you're going to need that low frequency response. So we've done that. Don't want to do that again. Then we go to display and transform. No, that's not what I wanted to do. I flip the display. We go to transform and turn transform on. Okay, now it's in TDR mode, and we want low pass impulse. Right, now there's nothing connected at the moment, obviously, so I'm going to connect this length of RG58. With no termination on the end, of course. So now what have we got? Well, I can get it. So now we've got a nice peak there. I'll move to that peak. That should tell me I forgot. I don't know if I should have set the velocity factor. It may already have kept it from previous times. Okay, it hasn't made any difference anyway, but we get more or less on that peak. Okay, that's telling me that cable is 772 millimeters. Fine. Let's measure it and disconnect it. Bring in my rule. In fact, this rule is not long enough. It's only up to 600. Here's a proper rule. Right, so stick that at one end. So that's measuring at I think I said 772 on the analyzer, so it's not far out. It's 779. 779. Okay, well you're going to get a little bit of inaccuracy, I guess. Maybe the velocity factor isn't quite 66% on this piece of RG58, but the other application, of course, is if you've got a piece of coax with a break in it somewhere, and you want to know where that break is, then in theory this instrument will find it for you. So I'll just go and try it on a long piece of coax and see what it does. Okay, so several days later I'm going to try and measure the length of this RG58. It goes to my active loop antenna, and this piece of cable goes all the way back to the house. So I'm guessing it's about 50 meters long. I mean, it's made up of several pieces, so I've never actually measured the total length. But problem I've been having now is, to do this test I need to use the nano VNA outside, and it's just been so sunny the last few days. The main problem with the nano VNA is it's just not, the screen display is just not bright enough to use it outside in the sun. You'd have to be doing it at night or on a very cloudy day. Now, today it's been cloudy and sunny, alternating. So I'm hoping in the next few minutes the clouds will come over again and I might have some chance of seeing this screen. I can see it, but you may not be able to see it very well at the moment. So I'm just going to wait now for the sun to go in. Okay, well the sun doesn't seem to want to go in, so I've moved under a bush, sort of, which is a bit more shady. I think you can just about see the screen now. And I've got to connect this cable up to the nano VNA. But what I've done on the nano VNA is I've set the start frequency at 50 kilohertz and stop frequency to what was it again? Yeah, 10 megahertz. 10 megahertz stop frequency, because if you're measuring a short cable, you're going to want a high stop frequency because the pulse reflection time is going to be shorter than with a long piece of cable. So now I'll connect it up and see what we get. I don't know what all this means when it's got no connection, but hang on a minute. Okay, I've got the cable plugged in there, down there, and of course not forgetting to unplug it at the other end, because if I'd left it connected, not only would it be terminated and you wouldn't get a reflection, also I'm feeding 12 volts up it, and I don't know if the nano VNA likes 12 volts up its backside, but it may have a capacitor blocking it. It probably has, but I wouldn't want to stick volts into it. So we've got some various peaks here. I think the main one is the one to look at. So if I move that down, that marker, difficult. Right, where's my, move that marker onto, as much as possible onto that peak. Okay. Now, up in the right, top right, I'm getting a 500 nanosecond reflection time and a 61.7 meters length, which I guess sounds reasonable. It's, what's that in English? 61 meters, about 180, 190 feet. So, yeah, because it's going all around corners and stuff and things like that. because I'm only really 100 feet from the house, but it has to go around different objects and whatever to get into the actual room. So 61 metres sounds reasonable for that length of cable. So if I needed to buy a new cable, then I'd know I'd need at least 61 metres. So there you go, that concludes this, I think. So that's another sort of technique you can use with the nano VNA to measure cable lengths. So bye for now.